Hello there folks, well it's Friday and we're going to do an Audioline 340 which is one of my sets, and it's going to end up on eBay if we can get it to work. So can't remember whether it's one we bought from Lincolnshire or just one that's been purchased down the line. Anyway, Mark says squelch loose. It's quite a faff to do that because you've got to take the front off and take away the front printed circuits. Signal meter not working. So we'll plug it into the test gear. So it looks to me like Mark has come to the conclusion that it works, apart from those quite important that not if you understand. At the end of the day, if the speakers inside the setting works, which is 16 ohms on these, and if the phase lock loop chip works, we're well away. Brand new mic, so standard replacement brand new mic, which will go out with it, and then brand new power lead will go out with it. I'll just plug in with our usual. So we're going to do the capacitors. I think it's got all 6 screws in this, which is remarkable. Oh, hasn't, it's got 2 missing. Poured boiling water on 2 fingers whilst there. Only for like half a second, but it's the worst thing a church organist can do, isn't it? So it all looks there. Tell you what, we'll power it up and hear that speaker works. Plug a mic in. Yep. So we can unsolder that now. It doesn't look messed with this, but there you are. We don't know. No, looks fine. Right, I've selected channel 20. So I'll start making some notes. I can just about start to eat some warm food now. My treated tooth settled down a bit. I'm not coughing quite as much. I think we've only got another 6 weeks of that. I've got a chest x-ray next week at the hospital to make sure that's going right. So what we got here, 1701088. I was going to say, when I was younger I didn't have these issues. Well, you know what, I had to have my gallbladder out when I was 39/40. Certainly knew about the pain before that. Happy week in hospital. 19, I don't know what the date is, I don't care. Audioline 340. Our set. So we'll be doing the 4 capacitors, but we'll make a go, because I know perfectly well if we don't do those 4 capacitors and we sold this, it'd be back within 3 days. Right, let's plug the test equipment into the extension speaker jack, then we might be able to actually hear what the radio is doing. Right, I picked picture-in-picture on, then you can see that what I'm getting. So we're going to start off in the 3 watt scale. 3 watts is full scale deflection, and it's doing 2.4 watts. Just checking we're at 13.8 volts, which we are. 2.4 watts. It's doing 2.4 watts on channel 40. I bet it's doing 2.5 on channel 1. I'm right, it is. It's easy to generate the low frequencies. Good. Low power. It's supposed to be 0.4. Oh, that was low power. Okay, so in high power, it's 4.4 watts. So it has had finger trouble, hasn't it? 4.3 watts. I'll just alter the 4, it's near enough. Yeah. And 4.5. So, yeah, it's over the top, which will end up killing it. TX current 1.07 amps, which, hang on, I'm doing that on the wrong channel. 1.05. I'm not going to do the VCO on this one. So it's not being messed with in that direction. There's no sign of any prodding around the VCO coil. If you need to see how the VCO is done, measuring point is here, and we've done it plenty of times, and you can look in the back catalogue. So we're not doing the VCO. Deviation. See if my meter's working today. Well, it says 1.5, but that might be right, it might be wrong. Frequency. Let's go over to the frequency counter. Now, these aren't adjustable. That's alright. I'm not going to put it down yet because the test gear's only been on 20 minutes. When the test gear's been on an hour, we'll take a reading. I think it's going to be about 27.79115. Of course, it should be 125. But if it was 27.78077 or lower, I'd be looking to change the crystal. But we don't really need to. We certainly don't need to do that because that's spot on. And if you start getting to 27.78025, you're starting to be so off frequency it starts to become illegal. Right, the RF meter when we key up. Oh, of course it doesn't work, does it? Mark said so. Meter lamp's working, that's one thing. Switches work. So, it doesn't have PA. Let's look at receive. I've got a fly in here. We don't have a window that opens. There's a little window in the kitchen in case I burn the toast, but I haven't burnt the toast, and so we've not had that open. But I've got a fly in here. One of the few British homes that's all air conditioned. That's because of my hay fever. I'm living in quite a warm part of the country. I do have doctor's tablets for hay fever, but I only need to take them if I'm going out, especially if I'm going to a church for a wedding and it's full of flowers. There's nothing worse than your eyes watering and all the music turning into wiggling tadpoles on telegraph wires. Right, let's have a look at the receive. Well, it's certainly receiving. Now this is exceptionally good. It's 0.39. A lot of these are between 0.7 and 1. They're not usually as sensitive as Cybernet sets, and partly they've got a better bleed over thing record, probably because of them being less sensitive. Yep, that's what it says. Let's look at. It's no good you looking at that. How about look at the SINAD meter? So let's put it to 10, about there, 0.33. .95. Squelch. Put this to a attenuator. You can see what I'm doing. That's not the attenuator. That's the oscilloscope. 3, 10, 30, 100. That's no good. Doesn't come in. 300. See where it comes in. 210 is tight. That is fine, but I like it to be 100 microvolts. There isn't a hard and fast rule on that, but that's how I like it, and that's from experience. Right, we'll turn the squelch down. Turn the signal generator off. Set threshold on the squelch control. Signal generator back on. It's coming in at 0.9. That's excellent. So we'll probably improve that. The speaker's working, and it doesn't come with the mic, it's new. We'll put new. So basically it's working, it's over power, and that doesn't help the radio's life at all. And it's certainly been pre-loved, hasn't it? Has it got a dent there? That when they threw it in a skip? Yeah. So my next thing to do is to change these capacitors, because, as I say, it's absolutely vital. So we'll get the rest of the screws out. We're going to change 220, 220, 470 and 470. And Mr. Chippy says there's another one we need to change. I think it's there. It's in the doubler. And if that plays up, you lose the phase lock loop. He's had that. $10 microfarads. I'll check with him anyway before just changing things willy-nilly. How come I left a screw in? Must be losing the plot. Yeah, you can't see any shenanigans on this side. So it's just had the phantom screwdriver tweak it up in inverted commas. I presume these people are the same people who drive cars at far too high revs in all the wrong gears. Yes, in the UK, gears are part of cars. Or because we do driving test when you learn to drive. If you do it in a manual car, you get a full license. If you do it in an automatic car, you get an automatic only license. And then people say to you snobbishly, as they see you driving an automatic, "Oh, I thought you'd be able to drive a proper car." That's it. Honestly, that's how it goes. So, seeing as one of our cars, the one we use as a test, is a Nissan Leaf, which of course is electric and doesn't have any gears anyway. You know what it says on the logbook? It says automatic, but it isn't automatic, it doesn't have any gears. So they haven't got that right, have they? So, the dot indicates positive on these. Just take them all out. Get them tested. We're going to throw them away anyway. This is where you get the silly Billy taking them off a scrap chassis. And of course the ones on the scrap chassis are just as knackered. There's many a time we bought scrap CVs and found the original fault as to why it was scrapped. You think, what a waste. And I keep going back to that Mustang 3000 we've got smashed up. Heartbreaking. If I had an ESR tester on here, I'd test these. But I haven't, so I won't. Right. Have we got any here, or do I need to go to stores and get some? I need to go to stores and get some. Right, so let's replace those 4. And these are Nikon 105 degree ones, high grade. Not Billy No Mates. Switch the set back on. You never know, it might still work. I did connect the meter up, the wires were snipped, probably because the meter's knackered, but I did just solder them back on just in case. Well, the meter works. What's that about then? Was somebody going to take it out and scrap the set for the meter? For perhaps well, these meters will fit in a Fidelity 1000, and perhaps they wanted to do a Fidelity 1000 up instead of having a uniden. How bizarre! Right, let's go through it. Well, the tuning can't be that far out, otherwise it wouldn't be doing 4.4 watts. It needs to be checked. They might have got something in the wrong sequence. So, we'll go over to... I'm just a bit over the time I needed to do something else. You have to remember the two-way radio part of the business is secondary. But we'll just run through this. We're looking for the centre of the peak, not just the peak. I'm showing you not showing you the right meter. Yes, I am. That wasn't the centre of the peak. Can't remember whether that's transmit or receive. It's transmit. I could always get the service manual out, couldn't I? We always use the realistic TRC 2000 service manual. In fact, we're going to be doing one of those sets. I've got a tired looking one, and that company do the stick-on replacement fronts. I bought a front for the... they're always a bit weary, aren't they, on those sets? But the sets are probably better than any other uniden. I'm absolutely convinced the realistics were the best set up uniden boarded sets there were. So we talk about the realistic 2000, the realistic TRC 2001. And so then the power is reduced with L10. Which is there, 4 watts. And now 4 watts is about 7 good buddy watts. Right, so channel 40, 3.9 watts. Channel 1, 3.9 watts. Channel 20. So we'll just take it a fraction over without the powers that be knocking at the door. Taking that to 4.05. Channel 40, 4. Channel 1, 4. That worked, didn't it? 4 watts, 4.05 watts, 4 watts. I think we're allowed a 10% measuring error, so that's within. So, this low power thing was a cock-up, wasn't it? But I'll do the meter first. meter is RFM there. Helps if we go to channel 20. It's probably going to take me longer to tighten that squelch control. It should be in the centre of the red zone, which it is. Excellent. Now, low power bizarrely was doing 2.5 watts, wasn't it? We're on the 3 watt scale now, so it's now doing 2.3 watts on low power. How stupid is that? It's now doing 0.4. And our current consumption, if we go back to full power, is 970 milliamps on full power. Right. I think we can just run through this receiver. I'll do everything except the deviation, and then we'll come back when I've taken a break and check the frequency. So at the moment, if we go to the frequency counter, the radio is on 27,79111. So we'll set the signal generator to 27,79111. So the alignment is how the radio is at this stage. It's a 100 microvolt signal on. Let's look at the oscilloscope. Check the detector. Which is spot on already. I'm not think we're going to gain much out of this because it's working so well anyway. So turn the signal down till we get about 4 dB, or it's about 6 at the moment. Like that. And then we'll go through the front end. That's already spot on. I'll probably end up fixing it worse. Put a bigger signal on for that. Go back to a smaller signal. It's about there. And then there's a VCO, part of the VCO, which you can do with an oscilloscope to a test point 2 I think it is. We can just check the amount of injection into the receiver from the reference oscillator and just see on the SINAD meter whether no, that's everything's peak. So what we'll now do is get a new reading. So let's see where we are now. So for 12 dB, .39. For 10 dB, 0.34. 20 dB, 0.95. There's no difference. Just dancing around in circles there. Oh, spot on. The transmitter wasn't. Not just was it over the top, but it wasn't. How strange. Right, let's look at 100 microvolts on the meter. The signal meter's there. Well over the top, isn't it? There's 9. Now we'll do the squelch. So I'm going to turn the squelch to full. And I want to adjust the squelch preset until the squelch comes in. There we are. That's it, that's how we want it. And then finally we check with the signal generator off, set the squelch to threshold on the radio. And switch the signal generator back on. And let's see where the squelch is now for sensitivity. 0.93. It's basically the same as it was before. Right, so what I'm now going to have to do, I'm going to take the front and the knobs off. Good grief, that's going to be some fun. You don't call me fingers for nothing. I'll show you the piece of string technique. Probably end up having to do that with this set. But anyway, I'm going to have a break, and we're going to have to take the front off to get to this squelch control. It's a bit of a faff and a half. I think actually we've got to take the exclusion off, haven't we? Can't remember. Anyway, I thought I was going to have to do the meter, and I don't. Right, pause video. Right, we'll just do the deviation. I've plugged into the other test set behind me. Let's see what I find. Wow. I don't find anything. Why is that? Because the power supply's not plugged in. Switched on. That's better. Wow. That machine's right, you know, it's 1.5. That's far too low. Well, it makes a change, doesn't it? It's got cranked up power, but not cranked up deviation. Wallow. 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 It's 2. See what that sounds like. Testing 1 2, testing 1 2 3 4 5. Good. Okay, so looking at the mounting of the squelch control, what we got, and it looks like it's loose, and I'll tell you why that is. So if I find another set here, it's exactly the same. What happens is there's a nut holds the volume control, just like there's a nut holds the channel control. But if we take this knob off, oh, you'll see that there is actually nothing which holds it at all. So it's the way these are. And as you can see, if the knob's stuck out like that, well, what's also happening is the printed circuit's moving. So that's some of the movement. So the spring clip was off the knob, which is why it was up in the air, but it's actually absolutely fine. But I've tightened that up, put a nut on because the nut was missing, and that's how it is. So done the deviation. See, we're still on the other test set. Let's bring it back to this one. Wallow. That's not reading right today. Fair enough. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. So there we go. So that's it, and except we're going to see what Mr. Chippy says. I think it's that capacitor we need to change, but he knows and I don't on that one. We'll just finish off, basically finish off by looking at what frequency this thing's on. Let's go over to the frequency counter. 2779125, 79124 toggling 5. So there you go. Once the gear had warmed up, I thought it would come up to 117. It's 2779124. When these were new, they were about 27150. The two crystals drop with age. So there we are. So I'll just ask Mr. Chippy. Well, I think it's that capacitor we need to change, and we'll leave it at that. Okay, right, so just as a precautionary thing, we've changed the one in the voltage doubler circuit there, 22 microfarads, 22 microfarads there, 1 microfarad, 1, 2, 3, 4, 5 4.7s, 470, 470, 220, 220. So what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I've changed 12 capacitors. Right. Final check. Wallow. Testing 1 2, testing 1 2. Not got maximum deviation on this is 2.4. So I've changed some capacitors in case there was something there. 2779. Well, I've put it in the wrong box, haven't I? That it's 2.1 to 2.4 kilohertz. 2779 124 2779 124. That's all right. That's all right. Done. Right, we'll put the lid back on. Tone control works. That's really nicely soldered the way they do that. Take picture in picture off. So this will go out with a brand new proper power lead. One some of the ones we can actually get. Put a couple of screws in. So what's this? 1981. It's 2024. 43 years old in November. Isn't it strange though that do all these sets, but it's the unidens that need the capacitors? You know, you'd think cheap sets like the greats, you'd need capacitors, but no, it's the uniden ones. Right, pop it on the aerial. Oh, we didn't check if the internal speaker worked. Put the power on the cheating way. Yep, it does. Pop it on the aerial. Push the test gear off. Really sensitive set, this. One nano roger, one low power. One nano roger. Usual, just talking, no doubt with burners, swearing. We'll go straight to 31, ready for Mr. Chippy on the air test. So there we go, another set brought back to life. Now that's one's going to end up on eBay. So thanks for watching Audioline 340 from 1981.